All right, class, we're now looking at the first classwork example for this May 4th week. You should have your notes right next to you as we go through this, right? Remember, we just got done taking all of these notes about the characteristics of these three functions. We're going to use those notes, and we're going to try and go through and figure out, it says determine if each graph or table is linear, exponential, or quadratic, and then we actually need to explain it. So make sure when you guys are doing those PM student tests, you don't just tell me an answer. You're not going to get any credit. You need to explain why you're doing that, either in words or try to use that math print to type it, right? I will gladly take a sentence if you don't know how to type in the math words. Okay, so first example, we have a table of values. So just going back here and looking down at my notes, if it's a linear function, which is this red category, I know that when I'm doing my table, the first difference is constant. So I'm taking the second number and subtracting, right? 0 minus a negative 3 is 3. 3 minus 0 is 3. 6 minus 3 is 3. 9 minus 6 is 3. If the first difference is constant, I know it's linear. If the first difference isn't constant, but the second difference is constant, I know it's quadratic. And then if I can divide my consecutive numbers and get the same ratio, then I know it's an exponential function. All right, so easiest way, in my opinion, is always check the differences first. So 0 minus a negative 6 is 6. 6 minus 0 is 6. And 12 minus 6 is 6, right? So right off the bat, I know it is a linear function. And then now in words, because the first difference is constant. That's it. Done. Right? My first difference was constant. I'm going up by 6 every time I make a jump. All right, question number 2, I am now looking at a graph. All right, so right off the bat, I know it is not linear because it doesn't keep going up at a constant rate or going down at a constant rate. It looks like it's going down pretty quickly and then it kind of levels off. All right, let's check to see if it's quadratic. What we know about quadratic functions is it has a minimum or a maximum. It has a vertex somewhere, some sort of like turnaround point. So yes, this is going down. It looks like if I just had this part, I'm like, okay, maybe it's a parabola. But does it ever bounce and come back up? It doesn't look like it, so it's not a quadratic. This looks to be an exponential function. All right, and then we want to say because it is decaying or decreasing, right? They like to use the word decay in exponential functions. It's decaying rapidly, right? Then that should be good enough, right? It doesn't have that vertex. You could also mention something about that. It doesn't have that minimum or maximum. It doesn't look like a line, right? So you can prove this by kind of like negating all of the other options. We already decided it's not linear and it's not quadratic, so has to be exponential. All right, looking at question 3, we have those same exact 3 options. Does this look like a line? Is it going up forever at the exact same rate? Is it going down forever at the exact same rate? That answer is no, it is not, right? Does this have some sort of vertex? Does it have that turnaround point? It looks like it does. It looks like right about here, my function's like, okay, I'm going up, going up, and then I reach the top and I have to go back down, right? So that is a parabola, which is not my answer. My answer is quadratic function, right? Parabola is just the shape that it makes, right? And then you might want to say, because there's a vertex, because it makes that parabola shape, right? Just give me some sort of math reasoning for that. All right, example number 4, looks like we have a table. All right, so I always like to just double check my x values, like I'm going up by 2, going up by 2, going up by 2. So then once I know that these are going up at a constant rate, I don't really need to look at them anymore. I can just kind of cross that off. All right, now I'm strictly looking at my y values. It looks like you go down 4, but then you go up 4, and then you go up 12. So my first difference is not constant. So right off the bat, I know it is not a linear function. All right, now let's ask ourselves about a quadratic function, right? You just have to kind of do this. You got to check all these cases just until you get really comfortable in determining which is which. All right, so let's see if we can take that shortcut. That shortcut is when I'm looking at my y values, if they are decreasing and then increasing, or increasing and then decreasing, then I know it has some sort of vertex. So here, it looks like you went down 4. But from -4 to 0, it looks like you went up 4. So do you see that change in sign right here? Right? I went down 4, but then I magically started going up 4 again. This is a signal that you have a vertex, right? You changed your direction, right? We know that linear functions do not have vertices. We know that an exponential function also doesn't have a vertice. So the only option is it has to be a quadratic function, right? It has that turning point. If you did not notice that, we would have to continue to go through and figure out that the second differences were constant. All right, so I wish I wouldn't have written all over that space, or I could show it to you. So I'm gonna just try to jot it down here. I'm gonna try to write over top of it. We went up 12 here. All right, so we have a -4, a 4, and a 12. I'm just gonna write those numbers down here just so we can see it. -4, 4, and 12. So I know it's not linear. The first differences aren't constant. But from a -4 to a +4, you went up 8. And then from a 4 to a 12, you went up 8. So the second difference is also constant. So that is another way that we could have proven that it was a quadratic function. All right, last one here. It says, the number of people infected with chickenpox each day is displayed in the table. All right, so we have, it's just 1, 2, 3, 4. It's just in rows instead of columns here. Right off the bat, if I'm checking my differences, I'm going up 60, but then you go up a lot more than 60. So you definitely know it's not linear. If you notice, look how quickly these numbers are going up. 30, 90, 270, and 810. Like that is a quick jump, right? So that should kind of signal in your brain that it's growing very, very rapidly. It might be making this kind of shape. It's growing very, very rapidly. So let's just check to make sure, because right now I'm thinking that it's going to be an exponential function. All right, the way we check that is we take the numbers and we divide them. We find that common ratio. So I'm going to do 90 divided by 30, and that gives me 3. All right, so I did 90 divided by 30. Now I'm going to do 270 divided by 90. That also gives me 3. Then I'm going to check 810 divided by 270. That also gives me 3. So I have that common ratio of 3. When I divided my consecutive terms, I got 3. So therefore, we know it is an exponential because it has a common ratio. All right, guys, make sure you view all of these videos, try all of these practice assignments before you even attempt that assessment on Wednesday, right? Make sure you get all of your questions answered. Keep learning, guys. You guys are doing a great job.